So I'm John Walsh. I'm a research professor here in the International Arctic Research Center. I've been working on Arctic topics for about 30 years. My original interest was in sea ice. As climate became a more pressing topic in the research agenda, I've broadened the research to include climate in general with a focus on the Arctic.
So what is climate?
Climate, to most people, refers to the average weather over a period of time, but it's really more than that. It's not just the averages, but it includes the range of variations and the types of variations that normally occur in weather at a particular area over a period of years or decades. So in a mathematical sense, we're referring to the distribution of weather over a period as long as several decades. That would be the official definition of climate, but I think the important point to stress is that climate is more than just averages. It includes the ranges, the extremes, and just the normal variability that accompanies the weather in a particular area.
What is climate change?
Following on the definition of climate itself, climate change would be an alteration of the prevailing weather patterns. It would be a change in the statistics of the weather over a period of years or decades. And it's important to remember that we're talking about a period of years or decades when we refer to a change of climate. One year can have a number of different weather variations within it, and the weather of one year does not comprise a climate, and it does not let us make inferences about climate change. When the weather patterns change systematically over several years or several decades, then we have what we would call a climate change.
What underlies global warming ideas?
Global warming refers to an increase of temperature essentially everywhere in the world. The implication is that what's causing that change of temperature is global in scope. So there would be a driver of climate, that is at work globally, and that driver was presumably undergoing a change that works in the direction of a warming, an increase of temperature that pervades the whole globe.
What is well understood in climate change?
Climate change is a complex topic. We understand some of the basics. There are a lot of things we don't understand. We do understand the major drivers of climate. We know that the sun, for example, is a major driver of climate. The sun goes through cycles in the way its radiation is distributed over the Earth. Those cycles last tens of thousands of years, and they're related to the Earth's orbital parameters, the parameters that describe the Earth's orbit about the sun. So that particular driver causes climate changes that are associated with things like ice ages that occur over tens or hundreds of thousands of years. On shorter time scales, there are drivers of climate such as volcanic aerosols or greenhouse gases that we know affect climate, and we know that these drivers are changing. Volcanic aerosols, for example, come and go with major volcanic eruptions. Greenhouse gases have been increasing fairly systematically over the past century or two. We know that. And we know that an increase of greenhouse gases leads to a warming at the surface because gases like carbon dioxide and methane are very effective at trapping infrared radiation and having the atmosphere re-emit it back down to the surface. One thing we don't know in connection with the greenhouse gas forcing is how water vapor enters into the picture. Water vapor is the strongest naturally occurring greenhouse gas. It actually accounts for more infrared radiation at the surface than carbon dioxide does. We don't know just how water vapor is changing in the atmosphere. We don't know how it will change as climate changes. We don't know how clouds will change, and clouds can effectively change the amount of long-wave radiation, infrared radiation reaching the Earth's surface. So there are secondary drivers, including water vapor, clouds, that we do not have a good handle on, and that in turn is holding back our understanding of climate change.
How does climate and climate change relate to the polar regions?
The polar regions are what we call amplifiers of climate change. When climate warms or when climate cools, there tends to be a stronger warming in the polar regions than in mid-latitudes. That pattern is called polar amplification. And it's true of climate changes that are occurring naturally. It's true of climate changes that are occurring in response to external drivers, such as solar forcing or volcanic impacts, greenhouse gases. What we've seen over the last 100 years or so is that the polar regions have warmed about twice as much as the rest of the world. So we're already seeing an example of the polar amplification of a climate change just in the past 100 years or so.
Why is the Arctic more sensitive to climate change than the rest of the planet?
The Arctic is more sensitive to climate change than essentially any other area of the globe. And the reason, the physical reasons are grounded in this notion of polar amplification. There are several reasons for the polar amplification, and in turn several reasons why the Arctic is more sensitive to climate changes. One of them has to do with the reflectivity of the surface. The ice and snow cover in high latitudes are highly reflective. If you warm the climate, you reduce the amount of snow and ice. That darkens the surface, allows for more absorption of incoming energy and an enhancement of the warming. So there's a feedback there. You warm the high latitudes a little bit, you amplify the warming by this what they call ice albedo feedback. Another factor that contributes to the enhanced warming in high latitudes is that the air that is coming into the polar regions from lower latitudes also has more energy in a warming climate, and it has more water vapor as well. When climate is warming, the atmosphere tends to gain water vapor. So we are bringing more water vapor into the high latitudes. The high latitudes are very sensitive to the amount of water vapor in the atmosphere. That further accelerates the warming that would be measured at the surface, and it's that warming that would show up as the greater sensitivity to the external drivers.
What changes are being observed in Alaska?
Like the rest of the Arctic, Alaska's warming. There's no getting around that. Over the last 60 years or so, the average temperature in Alaska has increased by about 3 degrees Fahrenheit. It's increased by about twice as much in the wintertime. So winters are 6 or 7 degrees Fahrenheit warmer than they were back in the 1940s, 50s, and even the 1960s. So we've seen a warming in Alaska. The growing season is increasing in length. That's consistent with a warming. Spring is coming earlier, autumn is coming later. So we're having essentially a longer summer season. We are seeing increases in the ground temperatures, especially areas with permafrost. The ground below the surface is warming at a somewhat slower rate, but it's a systematically detected warming. We're seeing losses of sea ice in the oceans around Alaska. The Bering Sea, the Chukchi, and the Beaufort are losing their sea ice. They're experiencing longer periods of open water, and one of the consequences of the longer open water seasons is that storms are more likely to occur when there's open water, and the result is that coastal flooding and erosion is increasing along the western and northern coasts. So we're seeing a suite of changes. They're all consistent with each other. But the bottom line is Alaska's warming, and it's losing ice cover, and there's no reason to think that those changes won't continue.
What are the models predicting will happen, particularly with what happens in the motion of climate, or the motion of synoptic systems?
The models are predicting, in a very broad sense, the types of changes that we're already seeing. In other words, the models are projecting that what we're seeing will continue into the future and perhaps even accelerate. So we can look forward to a warming climate, a loss of sea ice, especially in the summer and autumn, along the lines of what we've already seen. The models are projecting that soil temperatures will continue to warm. The result will be thawing permafrost in much of the interior part of Alaska, where permafrost is near the freezing temperature now. And the models are projecting increases in coastal impacts of storm systems. Even if storm systems do not increase in frequency and intensity, the coastlines will be more vulnerable because sea ice will be essentially out of the picture for a larger portion of the year than it is even now. So we'd be seeing a continuation of this loss of the sea ice and the loss of the protective buffer that the coastlines have had, at least in past decades. One thing that's not so clear from the climate model projections is whether storms will actually become more intense. There's a debate about this in the hurricane community, and that debate could also be applied to the storms that affect middle and high latitudes, including Alaska. On the one hand, with the loss of sea ice, storms will have more moisture to draw upon. That means more latent heating that gets released in the clouds of the storm. On the other hand, with the Arctic warming more than lower latitudes, we're reducing the contrast in temperature between the tropics and the polar regions. And it's those temperature contrasts that storms feed on. So on the one hand, the temperature contrast argument, we would expect weaker storms. On the other hand, with the increase in moisture, we would expect stronger storms. So the jury's still out on that one. But I think we can be confident that we're going to see a warmer Arctic, a warmer Alaska, and one that has less ice on sea and on land.
What might our children expect to see?
I think our children can expect to see a different climate. We're talking several decades down the road here. If we're talking about grandchildren, we're talking about perhaps half a century down the road. The warming that has been measured over the past 5 or 6 decades is probably on the order of the temperature change that will occur between now and 50 or 60 years from now, at least according to the climate models. So our children will see not just a warmer climate, but they'll probably be starting to see the impacts. The impacts will include the thawing permafrost, and in some areas instability of the ground as a result of the permafrost thaw. They're likely to see a forest, a boreal forest, that's more vulnerable, more stressed by the longer summer seasons and the increased drought stress. So there will most likely be increases of fire, insect infestations, which do put the forest at risk. We already have a boreal forest in Alaska that has been called at risk or stressed by the forestry experts, and that's likely to become worse over time. Our children and grandchildren are likely to see smaller glaciers in the southeastern part of the state. These glaciers have been retreating over the past 50 to 100 years and even longer, and that will almost certainly continue. So there will be some visible impacts of the changing climate that our children and grandchildren will see more than we have seen.